So let's get started. So welcome everyone. Welcome to another RISC-V technical session. This one is going to cover some results of the latest RISC-V mentorship on making RISC-V a first-class citizen on KernelCI. It all started with a need that we have within the RISC-V community. So we need to ensure that RISC-V goes, or is well represented in key places. And we understand that being, say, a first-class citizen in KernelCI is really important, given that without that, a lot of other stuff or a lot of other items won't be able to succeed. So we put this in place. We got over 200 applicants for this position, and out of those, we selected Camila and Simone to be part of this mentorship. As part of their initial effort, we realized that in order to contribute to the KernelCI, there was some real need to fix some areas that could reduce the entry, or remove at least, or improve the entry barrier, make that easier for anyone to be able to collaborate. And that they're going to describe their work, they're going to present that, but I'd say we are right now in a better position compared to what we have found when we started this. There's a lot of work to do, for sure. It is not the final destination, but we understand now better what should be done, and what are the priorities. So this mentorship is ending, but we have another one starting to continue on their work. So a lot of the improvements and the development they have done will be used by the next mentees to continue improving RISC-V presence on the KernelCI. So without further ado, Camila, Simone, please go ahead and present your work.
Thank you, Rafael, for the introduction. My name is Camila Alvarez, and I'm here with Simone to tell you a little bit about the work we did in the mentorship, all the different, challenges we had to approach, and finally the results we got. So to give you an idea of what we'll be discussing today, first we'll start a little bit with the context about KernelCI and the whole challenge we were trying to approach. Then we'll discuss the first steps we took to later just discuss a little bit about KernelCI itself and how it's currently working. Then we have what we call the RISC-V labs, which is mostly involved with some work we did, and the results we obtained, and finally what we expect would be the next steps for the next mentorship. So to start with the context, the first thing I think it's important for you to understand is about KernelCI is about the kind of project we're talking about here. This is a community-based open source distributed test automation system. The idea is to create like a central source of truth where people will be able to access via dashboard different information regarding builds and tests. So KernelCI offers an infrastructure that allows building different trees, testing them in different ways, and even you don't really need to depend on KernelCI infrastructure. You can use your own and submit results there. They even allow connecting external infrastructure to the whole system. The main idea is to improve the Linux kernel stability. And well, this is a project that's supported by the Linux Foundation. So in the initial state, what we found is that regarding the presence of RISC-V in KernelCI, RISC-V was not in a good place testing-wise. We only found that there was builds only for basic configuration files, and there was no sort of testing for RISC-V at all. That was mainly because there were no RISC-V devices connected to any lab that was connected to KernelCI, not external labs or inside their own infrastructure. And we also knew that there was some interest from the Linux community to see results for RISC-V and KernelCI. Later on during the mentorship, we found that there were some efforts to enable some RISC-V devices in KernelCI externally and internally. And also there were other companies working on enabling RISC-V devices in a lab. So with that, all of the information I just gave you, we defined a series of objectives. So these were mainly related to creating and exposing test results for RISC-V to the community, and also to allow kernel developers to run tests and receive results easily, and reduce the entry barriers for contributing to KernelCI for RISC-V, let's say.
Okay, so now that the objective has been defined, it was finally time to take some actions. So next slide, please. Okay. So the plan was the following. We first needed to understand the technical challenges between in building the kernel and actually testing the kernel. And so to do that, we exploited commonly used tools such as cross compilers, of course, for RISC-V, QEMU as a virtual device to easily boot and test the kernel, and then common CI tools such as GitHub Action, GitLab CIs, Jenkins, and others. We already had some existing scripts made from Rivos and RISC in order to test the kernel, so we already had something to work on. We took those scripts, we built some pipelines, and then we even tried to submit the results to KernelCI. So this was the plan, and this was actually what we did. Then next slide, please. Okay, so the first approach was this one. So we defined some, let's say, bare metal pipelines, and also some pipelines made with existing tools such as Linaro Task Suite that is made on purpose to build and test the Linux kernel. We tested first with let's say bare bones initramfs with only BusyBox, but also with full-fledged rootfs such as Fedora, that is one of the first rootfs, a distribution that is supporting RISC-V rootfs. We actually find some tests that are currently not working on RISC-V targets. And we also wanted to try with native RISC-V compilation, but we couldn't do it because of lack of resources. But it's something that we will do in the future.
So one of the first things we did after all the pipeline work was working on a sort of application that would allow us to take builds that were already being executed in KernelCI and test those builds. So what we did here was to make use of the KernelCI API that they had already developed, and that would allow us to obtain builds starting from a specific timestamp. So what we did then was to go and poll builds every 30 seconds. And each time we found a RISC-V build, we would trigger tests in a pipeline, which we called a test runner. So this app was pretty simple. This is pretty much the architecture. The central part over here is like the polling part. The RISC-V lab is the one that's calling the KernelCI API every 30 seconds, as you can see here, through their events endpoint. Also, these RISC-V lab kept the latest requested timestamp in a sort of database. So in case these, for some reason, the app went down, the next time we put it up, let's say, we wouldn't request all of the builds again. We will start by the latest timestamp that was stored. And then for each build we recovered, we would execute a test runner. We tested two different approaches. The first one is a GitHub Actions, which is pretty much what Simone described just now. And then we later implemented what we call the RISC-V KernelCI bridge, which is what I'm going to describe right now. So for this KernelCI, sorry, for this RISC-V KernelCI bridge, what we did was to create another app that worked as a test runner for the whole build system. The idea was to create a sort of app that would allow integrating different test backends. For example, linear attack suite or custom pipelines or any sort of test runner you could even think of. And also, it would not only run tests, but it would also perform the submission to KernelCI easily. So you wouldn't have to depend on any sort of upstream hardware or software infrastructure. This would be like a sort of easy start to contributing results to KernelCI without really having to understand much of their architecture. So to give a little bit more technical details on this tool, it was built on Fast API in Python. It can be easily deployed using a multi-container app, which is what we have right now. We actually have this deployed in an AWS virtual machine. And it has support for different database engines. And also, one of the key things about this project is that it also keeps a sync system that retries failed submissions, that also keeps us from resubmitting the same results over and over again. So this app is still pretty simple, but a little bit more complex than the other one. And for the first part, we have this client. In our case, the client is the bulk build systems, but it can be any sort of client that wants to run builds or submit tests or run tests. Then we have the RISC-V system, which in our case is mostly a bridge between test runners and KCI. So what it does is it tries to call a test runner. For example, it can be a attack suite. Attack suite might take a while running those tests. So once it's done, it's going to notify the RISC-V service model back. And then the same model will be in charge of submitting results to KernelCI via the KCI-DB client. Then all of the tests that have already been run and submitted will be stored in a database, which is going to have information regarding the submission state for each of the results. So if for some reason one of the results couldn't be submitted, the RISC-V sync service is going to take those results once a day, and it's going to try to submit them back to KernelCI, again, via their KCI-DB client. So I just want to give you a little bit of a demonstration of how it's working, this whole system. What I'm going to show you now is a short video on how I'm running a build here using this application. So at first, the first thing I'm doing right there, I'm just running the app. And what I'm going to do right now is I'm going to run a build through the API. You can see right there, I'm giving information regarding the tree I'm going to build, and the configuration, and the tool chain I'm using, and also the runner. In this case, the runner is attack suite. You can see there that the request was successful. So if I go into attack suite, I can see that the build is running. Now this is going to take a while, so you're going to see like a magical time skip. And now what I'm going to show you is how attack suite notified me that the build was completed. So if I go back into the attack suite website, I can see that the build was actually finished. So I was correctly notified of that.
Okay, so at this point, we knew what the technical challenges were, and we also knew how to interact with KernelCI. So next slide. Okay, so we just said what KernelCI is, but I want to remark one thing. KernelCI is an upstream effort backed by Linux Foundation. so it's really important to make sure that the stuff we do is actually maintained. And so we started moving towards the upstream project. Just to give you some more details about what KernelCI does. KernelCI does everything, including object storage for artifacts, test result parsing, it sends report to maintainers, it does a lot of stuff. So it's really a big and complex project. KernelCI does almost everything other than the, let's say, test job execution that is scheduled to other tools that we will see later. So this is the KernelCI architecture. It's not a one-to-one representation, but it gives you a nice idea about what it comprehends. So next slide. We can see. I will just go through really quickly. So Maestro is the KernelCI API. It allows to do a lot of stuff. So you can interact and schedule builds, get the artifacts from the object storage, and a lot more stuff actually. Next is the KCI-DB. So this stores the checkout events, the test events, and the build events log. Next, we see the KCI dev tool and actually other external tools that can interact in the same way. With KCI dev, you can interact with KCI-DB, with KCI. So you can get results from the KCI-DB. You can schedule jobs, fetch results, filter results, and everything related to that. Then there's the web dashboard in the next slide. The next dashboard, web dashboard shows the result. Of course, you can filter results and open the logs and do some kind of stuff. Next, there's the lab. KernelCI interact with a lab environment that is in charge of executing test jobs. The most common tool we will see later is Lava, the Linaro automated validation architecture, but KernelCI is compatible with other tools. You can even build custom pipelines as we did and schedule jobs on those kind of pipelines. KernelCI also allows to interact with other CI systems, such as Red Hat CKI, Intel Zero Day, and other tools. So next slide. Okay. So given the objective we set at the beginning, we found out two areas in which we want to expand and contribute. So first, we wanted to expose RISC-V test to the community in order to gain visibility, let's say. And we also wanted to lower the contribution barriers because we wanted to make other developers to participate and expand RISC-V support in KernelCI. In order to do that, we mainly followed one path that was to develop self-managed and easy-to-run environments. So everyone can spin its own environment, test their contribution, and see the results.
So one of the areas in which we collaborated was in the development of their Python client, KCI dev. This is a standalone tool for Linux kernel developers to interact with KernelCI. The main idea is to make the life of the kernel developer a little bit easier by allowing them to run tests or build or even get data that they can also see from the dashboard, but in a Python client through their console or even by connecting it to other pieces of software. So what we did here were two different kinds of contributions. The first one was to add different subcommands, trying to get these Python clients a little bit closer to what the dashboard is showing right now. So for instance, we added the build, test, and boot subcommands that allow any developer to obtain data on any specific build test or boot test. And And then we added a hardware subcommand that allows listing all the hardware that's available in different origins, summary of the results for each hardware, like number of tests, number of builds, and then obtain those set builds and tests and boots for each hardware. Then the other part would be like, I'd say, working on what was already available. So we added some contributions to a filter YAML file they had by allowing people to make more complex queries in the filter. We also assisted on the refactor of the client and also in an update of the API once they deploy that API to production.
Okay, so let's say you want to contribute to KernelCI. That's, for instance, to enhance RISC-V support. So how would you contribute and test your contributions to KernelCI? Of course, if you do small changes, you could just open a PR and ask for maintainers to deploy on staging environment and test the results. But considering the changes we needed to bring, it was necessary to have a way to test in an end-to-end manner, let's say, what we wanted to do. So deploying the development infrastructure was definitely too complex, and it was not suited for development use. There was actually an existing local deployment. There's a part of the code base that is related to the local deployment. However, it was not reliable and poorly maintained. One of the most important things that was missing is that there was no way to interact to KernelCI through the KCI dev tool. So you could not schedule manually jobs. And that was, of course, a problem. Another big problem is that there was no way to connect a local lab. So there was any local lab you could schedule test on. And that, of course, was a big problem. Also, the local deployment was not reproducible, and it was not working on our machine. It was giving different results. Next slide, please. So our work started from small bug fixes, but ended up refactoring the local deployment at all. So in all its parts. So we focused on the reliability on the local deployment first, and we followed a Docker in Docker approach for that. And as a result, we are able to deploy locally the entire KernelCI infrastructure without any issue on multiple machines. So that was the first point. The second point was to enhance the KernelCI deployment to cover all the services that was needed to test end-to-end from the kernel builds to the kernel test on the actual, in this case, virtual device, but we will see later that we also plan to extend to actual RISC-V real hardware. This was really important because it was not important only for us, but for all the developers that want to enter and start contributing to KernelCI, because this significantly lowered the barriers for new contributions, since everyone can start deployment, do some contribution, test and contribution, and send them to the KCI maintainer. And next slide. Then just to give you an overview, what was missing on the existing deployment, as we said, as you can see in the left, there was no lab environment, and there was no device in which you could schedule jobs on. Then next slide. So this is what we have now. We have the entire KernelCI infrastructure that can be deployed. The KCI-DB cannot be deployed locally right now because they are changing, the KernelCI maintainer are changing the REST APIs. So we will wait for them to implement this new API, and then we will port it to the local deployment. The web dashboard is not needed to develop locally, so it's not in the local deployment. So let's talk more about the RISC-V labs and how we schedule jobs on devices. So next slide. This is what we are talking about. So regarding what I described before, this is the lab that you can connect to KernelCI. Lava is the most used, commonly used software to implement a lab environment for KernelCI. Lava allows to deploy operating system, let's say on a programmatic way, to both virtual and real devices. Lava is mainly composed by one master node and one or more worker node. Worker nodes, they talk with the device under test, allowing to flash, boot, reboot, and interact with, in general, interacting with the devices. So again, we can have both virtual and real hardware. The first deployment that we have, the first deployment of the lab we have, is of course the composed by QEMU-based virtual devices. These allow to schedule jobs on a containerized development setup, and we are using now to validate KernelCI changes and to debug the pipelines. It's critical because contributors can use and deploy that environment without going through any hassle of setting up the hardware. And of course, it's a foundation to then scale to common RISC-V boards. The second iteration is still ongoing, and we have a RISC-V partner, Cloud5, that is working on enabling the Banana Pi F3 boards on Lava. So soon we will have an actual device, RISC-V device, that can execute test jobs defined by the KernelCI, our KernelCI deployment. And next slide, please. Okay, so when we finally had the local deployment, we were finally able to test those pipelines and finally schedule these jobs. And we finally were able to notice some part that was missing. So, for example, that for RISC-V, it was really important to track which root file system we were using when we were executing test jobs. Mostly because not every distribution is supporting RISC-V as an architecture. And in fact, most of the rootfs that are now available for RISC-V are in beta version. So it's really important to make sure that the job is failing not only because of the architecture, but also because of the rootfs we are using. We find those issues, and with our local deployment, we were easily able to contribute and add the missing stuff we need. So we open an RFC, and we added this link in between the test and the rootfs on the KCIDB. And now you can see a demo of the local deployment from the start to the beginning. So you can clone the repository from our fork. Then you can deploy the entire infrastructure. It will take some time, so this is 3 times sped up. This is starting the pipeline services, the APIs, the local Lava environment. And then at the end, we can see that, for example, we can reach the API viewer at this local URL. We see that there is no job scheduled right now. So first, before scheduling any jobs, we need to configure the KCI dev tool with the token to interact with our instance. We can get the token and set the token to our shell. After that, we are able to trigger events. So, for example, now I trigger an event on the mainline tree on the master branch, and you can see there's an event triggered here. This is a checkout event. So after some time, let's say a bunch of time, it will finally clone the Linux kernel. As you can see here, the job is still running. And logging here, you see that it's actually cloning the Linux kernel. After the checkout job is ready, you see a child job inside this one that is the kbuild event. So KernelCI will start building the kernel with the configuration you provided in the config. Again, you can see the status, and you can see that one build job is scheduled. You can see that one Docker container is spawned, and logging the logs of this container will show the actual building process of the Linux kernel. After some time, again, you see that the build job is completed. You see all the artifacts that are uploaded on the object storage, and then at the end, test events will be scheduled. Now they are already completed. You can see the artifacts again, and you can see finally here the results of the Lava job. You see here that Lava has received one job, and the callback has received the results. So Lava actually sent back the results to KernelCI. Here is the local Lava instance, and you can see this job scheduled. You can see the job definition and the job results. So this is an actual Hello World job. So you can see the OpenSBI bootloader started and the kernel logs that just started and printed an Hello World message. And that should be all. Okay.
Okay, so after all the work we did, what we wanted to see is that if we could actually submit some results to KernelCI and start displaying those results in the dashboard. So what I'm going to show you right now is how you can see some of the tests we have submitted to KernelCI directly from their dashboard. So what you have to do is go to any tree that has RISC-V builds. You enter one of those builds, and then you can go to the test results section, and then you can go ahead and start navigating the tests. If you see any test ID with RISC-V at the beginning, that means that that is one of the tests we submitted. That actually means that those test results come from a different origin than Maestro, which would be like the KernelCI API. Also, you can see all the tests we submitted and their results in the KernelCI Grafana dashboard.
And here's the final results. So you see that before the 12th of May, 2025, there was actually no RISC-V tests going on. But now, as you can see, that there are some, and this is just the beginning. Okay, so let's wrap up what we did and see what the next step should be. So what we've done is that now RISC-V test jobs can be correctly executed on QEMU. We are able to do that without any issue. And that doesn't mean that RISC-V testing is successful. We just mean that test jobs can be scheduled. We can deploy the full KernelCI stack easily. We are able to submit tests to KernelCI. And finally, that the dashboard is actually showing RISC-V results. So what should be the next step? First of all, we need to make sure that the pending contribution we have are correctly merged upstream on KernelCI. Then, of course, the integration of the real hardware to KernelCI, to the RISC-V lab is crucial, because we want to show the community real, meaningful results, not just results of virtual devices. And then, of course, expanding the test coverage, both in terms of the configuration of the kernel and the test suites, of course. And that would make RISC-V a first-class citizen in KernelCI. So thank you, everyone. I hope you enjoyed the presentation. If you wish, you can read the full report, scanning the QR code in the right. And if you have some question, please ask us. We will be really glad to answer those.
Thank you, Camila and Simone. So, as you saw, what they did was to come up with providing let's say, initial good starting point for everyone that's willing to contribute to RISC-V as part of the KernelCI. So we need more engagement there. We need more contributions. We need more active development, either supporting KernelCI as a platform or contributing to RISC-V integration and tests. So there's a long hold ahead, but things are moving forward. So now it's a little bit easier for everyone to contribute. So everything that they have done here, including the tools, will be available. So anyone will be able to use that and help improving that. But as we move forward, so as I said, we're going to start pushing now to effectively contribute to the RISC-V in the KernelCI. How we can fix broken tests, how we can ensure we have parity level between x86, ARM, and RISC-V. What is missing? What we need to add? So now we go one step further to ensure things can be done, and let's say that we can sustain that for a long period of time, because that's critical for us. KernelCI is important for RISC-V. I mean, getting the RISC-V builds reports done properly listed in KernelCI is key for the kernel maintainer, so that can speed up the development process, debugging and fixing issues, which at the end of the day is going to help the whole ecosystem. So as good as we can get on the KernelCI, better for everyone. So we continue moving that forward. This was just their starting point. As you see, they have done a lot in a few months, 3 months essentially. But now we continue. So if you are ready to contribute, and if you are ready to help, if you are ready to get, let's say, get involved with the KernelCI first as a community, and try, if you are willing to contribute to the RISC-V, maybe you can start by using some of the resources they have shared here. That's a good starting point. If you have a board, for instance, a RISC-V board, you can run tests locally and maybe even contribute those results. If you are a part of a company, maybe that company can start engaging with KernelCI on maybe sharing some resources or provide something to the project itself that can help RISC-V grow. So there's a lot of opportunity. So RISC-V is not only about there's a lot of opportunity for contribution to RISC-V that goes beyond developing a specification or developing RISC-V itself. Now we have opportunity on the software stack, so we need more people to help that on that front. So kernel is when you combine kernel and RISC-V on the same sentence, that becomes a hot kind of area to work on with a lot of good challenge. So feel free to contribute. If you want more details, or you can email them. You can also email me, Rafael at RISC-V or RISC-V.org, and then we can discuss about that. So, but I'll say at the first starting point, ensure you get familiar with KernelCI, maybe start contributing, get involved with the project, and help RISC-V grow on that front. So, any questions or anything for Camila and Simone that they can help answer right now?
I see there are a couple of questions on the chat.
Yeah, let me give Ellen the ability to speak. Hang on. Go ahead, Alan.
Hi, can you hear me?
Yes.
Yes.
Awesome. So, hello, I am Ellen. I used to work on the KernelCI team. This year, not so much. And I am really happy to see how things are evolving, how RISC-V is entering in the community and having more tests and improving its quality. So I would like to say thank you for this work. Thank you for contributing, and I feel that this is very important for the community. And as a former contributor, I am very interested how the architecture is evolving. So I have a few comments and questions and technical questions actually regarding the presentations, if you don't mind.
Mhm.
So the first thing that I'd like to clarify a bit when it's about the terminology that I was a bit confusing in the beginning when you say KernelCI. Usually we say KernelCI to the entire project, to the Linux Foundation project, right? So there's no piece of software called KernelCI. So for instance, in page 40, so if you go back to page 40, it's mentioning KernelCI and KCIDB. So this was a bit confusing. So what I think you mean there is Maestro and KCIDB. This is confusing also because Maestro used it to call KernelCI. So just want to clarify that. And if you go back to page 15, I have a few questions there. Yes. So you mentioned that KernelCI, which I think it's Maestro, builds the kernel for you. You pull that and you run tests on it using Tux. Is that correct?
Yes. Yes.
Right. So the build runner there is Maestro, right?
No,
Or
in this case, this build runner is an independent model that would allow us to run builds that Maestro is not running if we want. And
right.
we can also submit those builds to KCIDB if we want.
Awesome. So you don't depend on Maestro. You also build it. You
Yes.
also have a module to build it.
We can do both. That's the idea.
Right. I see now. The same thing, I have the same questions regarding like submitting to KCIDB. So you can submit it directly, or if you are using Maestro, so Maestro submit it for you, I suppose.
No, in this case, we're just using KCIDB directly for submissions, for test submissions.
Okay, nice. And the other questions that I have is, so you are using, so besides building, which kind of tests do you do?
We executed some case-off tests and LTP tests.
Awesome.
We are expecting the next mentees to expand that.
Yeah, that test coverage was definitely something for the next mentorship.
Nice. And I see that you also have a test runner. So I know that Maestro has some test definitions. So it runs a case of test and also other test suites. So I was wondering if the Tux suite is when you don't use Maestro and case of test is true Maestro or not? Or do you execute all of those just in your test runner without using Maestro?
Yeah, we're executing everything outside of Maestro since Maestro didn't have any support for RISC-V devices, not even virtual devices.
I see. Okay, I guess those were my questions. Thank you very much.
No, thank you.
Thank you.
Any other questions? So there's a question about, there's two questions in the chat. One, what are the, let's say, requirements for contributing? So maybe Camila and Simone can provide some high-level idea talk on that.
I would say that the requirements are just, let's say the KernelCI community, the maintainers are really open. You can interact with them on Discord. They are really supportive. So as long as you actually want to be engaged in the contribution, you are good to go. There's no there is no blocker as long as you are able to get involved and have some time to have fun with it. You're welcome. And there's also another question I see from my friend Tan. So I know that our Cloud 5 RISC-V partner is working on enabling the Banana Pi. Of course, there are also other efforts on KernelCI regarding enabling other RISC-V devices. For example, Collabora and Rise are working on other devices. I don't know exactly which devices, which board they are enabling. But of course, I guess that also maybe Rafael can answer better. But if there are other contributors or companies that want to enable other devices, I think they are more than welcome.
Yeah, let's say right now, let's say Banana Pi is one of the most accessible boards. We have the Sci5 is one. So those are the two main boards that we see people using. So and maybe enabling. We have some, I believe, other cases within Scaleway, but I'm not recall exactly what they are using there. Let's say Banana Pi or that board from Sci5, say the most used at this point. So I see Gustavo raising his hand. So Gustavo, go ahead.
Hello. Yeah, I want to say thank you. I think it's pretty good work. I think it's a nice first inroad of RISC-V into KernelCI, and as you all said, it's just the beginning. And also for the KernelCI infrastructure as a whole, like we've been bringing this together like for the past 2 years more or less, and it's a pretty complex thing when you look like from end to end into it. So it is taking us a lot of energy and effort to do it. So the more the community grow, the better for KernelCI. We have to from databases to services running Kubernetes to scaling things to kernel builds to engage with maintainers, test suites, root file systems, dashboard, etc., command line tooling. There is so many things to do, and it's great to see the community growing. Yeah, so thank you a lot for the work that both Camila and Simone did, and thank you for RISC-V International as well for supporting this and for continuing to support this in the future as well.
Thank you to Gustavo for all the support you gave us during the mentorship.
That's fun.
So Ellen asked about when we plan the next mentorship. So we have closed the call for candidates. I have received over 100 applicants again. So I need to go through the process to select who we're going to pick. Again, I'm going to try it with 3 mentees and see if that works out. Yeah, we should have that started the next 2-3 weeks maximum.
Awesome. This is great. Yeah.
And then another question here is about what steps should a new contributor follow to add a new test case to KernelCI? So maybe Ellen and Gustavo can answer these, or in Camila and Simone can provide their inputs also.
One of the easier ways is to contribute to OTP and case of test directly, and then we can very quickly bring that into KernelCI. If you need to bring, like today, would love for this to be somehow automated one day, that people can just like list the name of the test they want to run, and KernelCI will build a root file system for all the different architectures. But we're not there. Someone has to go and do that work by hand. So that's how you add. You go and add the test into KernelCI. If it's case of test in OTP, we have that already. So it's just like sometimes a matter of you building the root file system, and we get the test done.
Yeah, I'd say the best way is to start getting part of the community and ask hard questions to Gustavo and others via their chat.
Yeah, we are in Discord. There is I can throw the link for that. If people want to join us, let me just figure out where the link is. Yeah. And paste in the chat. Where is the chat? So that's KernelCI Discord. We are all there. Come and say hi.
Great. Any other question, folks? To anyone here? So, as I'd say, the last step on this mentorship, we're going to put together a short blog post with key highlights of these, including links to their source code and project. So anyone in the world will be able later to see and grab that information, start to work on that. And yeah, so if you're not a member of RISC-V, so join RISC-V and start helping. So we are pushing forward a developer relations special interesting group to help do some gap analysis on different open source projects and help start us understand what we need to do to address the issues there. And the kernel is one of them. So feel free to join RISC-V and start helping us. We have a lot of things to do and a lot of opportunities. So, and by the way, those two, Camila and Simone, yesterday had a meeting with Greg KH as a mentorship guideline for them on what the next step on their career should be. So it was a really good, let's say, closure for this mentorship. Get some advices from one of the key kernel maintainers at this point. Great. So folks, any more questions? Otherwise, we can close the session. No more questions. So I'd like to thank everyone for joining. Thank you, Camila and Simone, for all the work you have done in the last 3 months. Thank you, Gustavo, and the KernelCI project for embracing and supporting the mentees through all that period of time, because without their help, nothing could really have happened. And now we move forward to the next iteration. So I hope we can deliver more great results, because they set the bar too high. Now we need to meet that again. So thank you very much, folks.